Good morning everyone and welcome to another lesson on this time percentages. Before we start, let's just quickly look at what we'll need. So today we're going to be looking at how we can work with percentages, and for this you'll need a pen and paper as always, a calculator and access to this website if you would like to do more in-depth personal independent learning. So hbkportal.co.uk/mwb/home. The link is in the description, so all you'll need to do is just click on that if you want easy access to the website. So before we begin then, let's just quickly discuss a few of the basics that we'll need to be able to access today's lesson. The first one, well, what is a percentage? Well, having done a little bit of research into it, and in particular, having done a project on vocabulary, the word percentage isn't actually just a single word. It's actually broken up into several. So we've got per, cent, and age. The word per actually means for each, and cent means 100. Now, no matter how much research I did, I couldn't find a reason as to why the word age actually appears on the word percentage. If anyone does know and happen to find that answer, by all means, please do let me know, because I'd be very, very interested. One of the things I did find is that according to Google, they actually map how many times a particular word appears within literature, and the word percentage had more of a focus from 1850 onwards, but interestingly, over the last sort of 30-40 years, the word percentage has actually declined in common websites or books, which I found quite interesting. So, am I likely to encounter percentages in real life? I think this is one of the biggest questions that people always have when it comes to a math lesson, and for this, of course you are. So when it comes to percentages, I think it didn't take me too long to gather just a couple of examples. So we've got our first one here, which is percentages are actually the equivalent of any fractional decimal. So a half could be written as 1/2, could also be written as 50%, or it could be written as 0.5. The one thing that we're watching this video from is probably already telling you the percentage of battery that you've got left, or it could be that actually when it comes to things like statistical measuring, like data on a chart, we will generally possibly represent it as a percentage. Anytime we go shopping, we're likely to see how much percent meat content it might be, whether it's organic, or more importantly, whether we're actually getting any deals or not. So why are percentages seen everywhere? Well, one of the reasons for this is that percentages are a really useful way of comparing things that are not necessarily out of the same number. Take, for example, 2 packs of sausages. One might have 6 sausages in, the other one might have 10. Obviously here you're looking at a different quantity of sausages, but then you might be more interested in the meat content. So here a percentage would actually be really useful. So rather than telling you the weight of meat contained within those sausages, you're actually given as a percentage, which then does hopefully help with determining which is of a better quality. So, if we then think about the fact that when it comes to percentages, the most common use of this would actually be in exam marks. So when it comes to exam marks, we will generally sort of say, well, if an exam is out of, say, 10 marks, but the second exam is out of 12 marks, converting it into a percentage actually gives you a better idea as to how well you have done across those 2 papers. So I started to think about percentages in real life, and it didn't actually take me too long to suddenly realise that you could apply it to pretty much anything. So every single lunchtime over the last sort of couple of weeks while schools have been closed, I've been actually making my use of my time by having a Nerf gun battle with my son, so that we get a bit of fresh air and get outside. And one of the things that I've become quite used to doing as well is actually watching a YouTube channel called the Slow-Mo Guys. Now they basically take a shot of random things, whether it be a tank firing, whether it might be someone doing a belly flop on a pool. I suddenly started to think of what things I'd be quite interested in seeing in slow motion. Well, for this, I went outside with my son, and having just finished the Nerf gun battle, I suddenly started to think about whether I might be able to slow down a Nerf gun. So here's my attempt. So this was shot at 30 frames per second, and you can kind of see the bullet darting off, but it was very, very difficult to be able to analyze it. So I increased the number of frames by 100%, and I then did it at 60 frames per second. This time it was a little bit easier to be able to see the bullet. However, not happy with the fact that I couldn't really break this up the way I'd wanted to. I actually increased the number of frames from this point by 300%. And we ended up going to 240 frames per second. And this is what it then looked like. So I managed to sort of see that the bullet darted off, but I wondered whether if I could slow it down any more, I might be able to see if the bullet, like a normal bullet would do, which is spiral in order to make sure that it's actually going straighter, did actually do that with a Nerf gun. So I added another 300% of frames onto this video, and I managed to get it to 960 frames per second, and this is what it looked like. Clearly, I enjoyed that a little bit too much. But as you can see, it was really interesting that when it came to it, the bullet actually wiggled, although it looked like it was going straight ahead in a shot. It was actually wiggling through the air. So that's probably why I haven't always shot him when it comes to my accuracy, and that's what I'll blame it on. But notice how through that one simple example, I introduced the idea of percentages. And in this context, I actually talked about increasing the number of frames by a given percentage. So throughout today's lesson, we're going to be looking at how we can actually do that in a range of different contexts. So, let's talk about the basics again, because obviously we want to be able to scaffold this up to the point where we can actually increase by a given percentage. So how do we work out or convert a number into a percentage? Well, first of all, we need to be given it as a fraction or possibly as a decimal, so that if it was a fraction, I can convert it into a decimal, and if I've then got it in decimal form, I can then convert it into a percentage. There is always the case that if it's written out of 100, then I already know what the percentage is. But in this case, this fraction is written out of 4. So what we would do is the numerator divided by the denominator. 1 divided by 4 would then give me 0.25. And if I've then got it in its decimal form, I can then times it by 100, and then I've got it into its percentage form of 25%. And this works no matter what you do, and you quickly try this on a calculator. Let's say if I've got 3/4, 3 divided by 4 would give me 0.75, and times it by 100 then gives me 75%. And these are some of the common fractions, decimals, and percentages that we should know off the top of our heads. I think the more interesting one might be something like a third or 2/3, or even a ninth. And if you try this, you actually end up with quite a complicated decimal. However, once we have got it into its percentage form, what kind of things could I actually do? Well, some of the simple operations that you could do is actually find a percentage of an amount. And this is sometimes what you'll see in sales and things like that. You know, you've got 20% off, and this is where you'll need to work out what 20% of that amount is before you then take it off, because it's a discount. So how do you find 20% of a number? There's a range of different ways. One of them could be that you're using a calculator, in which case convert it into a decimal and multiply the number by 0.2. Or find 20% of 160 using a non-calculator technique. So for this, I like thinking of it as like pocket change. I'm going to use 10s, 5s and 1s in order to make up 20%. So if I can work out what 10% of 160 is, 5% of 160 and 1%, of 160, I can then combine any of those together to make my 20%, and then I can work out what 20% of 160 is. So how do I find 10% of a number? So in this case, we're going to use this as kind of like a quick example that if I've got to work out what 20% of 160 is, then one of the things I'm going to do is try and work out what 10% is first of all. So 10% in this case, if I know that 100% of 160 is 160, then you'll notice that I can divide this side by 10. Dividing it by 10 and dividing this by 10 will give me that 10% is therefore 16. Now, I could go on to work out what 5% is. Now, 5% is merely half of 10%, so half of 16 is 8. And I could work out what 1% is. So divide 10% by 10, that would then give me 1.6. So 10s, 5s and 1s, all I want to do is combine multiples of these to make 20%. And I can quickly see that obviously 10% is 16, so if I double 10%, that would give me 20% is then 32. So at this point, we've worked out that 20% of 160 is 32. So what if we then started looking at some other examples? So here I'm going to go for a my turn, your turn type approach. I'm going to work out the questions on the left hand side, and then I'll leave you to have a couple of minutes to be able to have a go at the ones on the right. So to begin with, let's look at the first question, which is 10% of 15. So 10% of 15, I know that 100% is 15. 10% is going to be divided by 10. And if I work out what 15 divided by 10 is, that will then give me 1.5, and that's my answer. The next question asked me to work out what 40% of 30 is. So I know that 100% is 30. Work out 10%, which I can get by dividing by 10. Whatever I do to one side, I'll do to the other. So divide it by 10 then gives me 3. So from here, if I know that 10% is 3, I could double it. That would give me 20%. And if I then double it again, I get my 40%, which then give me 12. And that would be my final answer. For the last question, it asked me to do 42% of 50. So I know that 100% is 50, 10% is 5, 5% by half in this is 2.5, and 1% is 0.5, because I'm dividing 10% by 10, divide 5 by 10 as well, and that gives me 0.5. Now in terms of my pocket change, in order to make 42%, I want to be able to do 4 lots of 10 and then add on 2 lots of 1% of 50. So 4 lots of 5, add on 2 lots of 0.5 would then give me 20 plus 1, so 21. So at this point, we've now gone through 3 different questions. Each of them actually use the non-calculator technique, and we'll have a look at how we can work out each of these questions as we come to check your answers in a moment using a calculator. But for now, what I'd like you to do is replicate exactly what you've seen using these examples. I'm going to give you the ones on the right hand side. I'm going to give you about 3 minutes to be able to have a go at these. Please show you're working on your pen and paper. Any questions, then by all means please use the comment box on YouTube if you're watching it off that platform. Otherwise, 3 minutes, off you go. Okay, one more minute. Okay, so let's go through these answers then. So your first question was 10% of 30. So if I know that 100% is 30, I can work out 10% by dividing by 10, which in this case would then give me 3. Moving on to the next one. If I know that 100% is 20, I could work out what 10% is by dividing by 10, which would then give me 2. Now obviously at this point I want to find out what 60% is. So I've got a couple of options here. I could either times this by 6, which would then give me 60%, and then I would know that this is then 12. The other option is to find what 50% is. Now to get 50% we half 100% by 2, and then just correcting that one, divide by 10. So at this point, if we divide this by 2, we can then find that it would then be 10. So if I've got 50%, which is 10, 10%, which is 2, you'll notice that the sum of these two would give me 60%, and the sum of these would then give me 12. So we'll come up with the answer, which is then 12. Moving on to the last one, I want to find 100%, which is 80. So 10% is then 8, and then I'm going to skip to 1%, so divide this by 10 again would then give me 0.8. So 31% is going to be made up of 3 lots of 10% and 1%. So 31% of 80 is 3 times 8 plus 0.8. 3 times 8 is 24, add on 0.8 would then give me 24.8. Now from here, we've again been using the non-calculator technique, so I'm interested to see how we can actually utilize our calculators if these types of questions did actually come up in a calculator paper. So to begin with, let's have a look at these same questions, but this time thinking about how they could be represented using a calculator. So I want to find 10% of 30. Now, as we saw at the start of the video, percentages can always be written as a decimal, and if we convert a decimal into a percentage by timesing by 100, I can convert a percentage into a decimal by dividing by 100. So this would then mean that 10% is 0.1. Of is commonly a word that means multiply in mathematics, so if we do 0.1 times by 30, I would then get the answer of 3. Same thing again with number 2, that 60% of 20. Divide 60 by 100 would give me 0.6, of meaning times, and I want to do 0.6 times 20, which would then give me 12. And finally, the last one, that if I need to work out what 30% of 80 is, 31 divided by 100 is 0.31, of meaning times, and times it by 80. That would then give me 24.8. Now, as you can see, if this was a calculator paper, it would be much more efficient to use the calculator technique in order to save time. Minimal working is required. That in this case, all I needed to do was convert the percentage into a decimal and then multiply it by the number. So we've looked at quite a few of the basics at the moment, and all we've done is work out the percentage of a number. However, I can imagine that at this point we are looking for some real-life applications of this, not just me firing a Nerf gun or simply just working out percentages of numbers. Well, the easiest context when it comes to percentage will be banking. So things like VAT, sale, interest, depreciation, costs, it could be anything relating to buying and selling of products. We are getting there, but there are a couple of other things that we need to attach onto our learning. So if we can work out, say, what 60% of 20 is, could we now increase a number by a particular percentage? So I'm going to run through this without actually saying anything. I'm going to ask that you try and assimilate the information on the screen because it more or less mirrors what we've looked at so far, but just in a slightly different context. So increase 120 by 35%. Okay, did you get it? Well, 100% divided by 10 will give me 10%. So 120 divided by 10 would give me 12. Half in this number would then give me 5%. In order to work out 30%, I times 10% by 3, and I got 36. Add on the 5%, 6 add 36 would then give me 42. So I've now got what 35% of 120 is. However, the question is, increase 120 by 35%. So what I wanted to do was, once I've worked out what 35% is, add it on to 120. This then gives me 135% of 120, so 120 plus 42 is then 162. So if I was then going to model what we've just seen using a calculator, then as you can see that what I wanted was to work out what 135% of 120 is. Because it was an increase, what I started with was 100%, and I wanted to be able to add on 35% because it was an increase in question. So 135 divided by 100 gives me 1.35. Of, meaning times 120, would then give me 162. Same answer, slightly different technique, this time using a calculator to arrive at the same answer. So let's think about summarizing what it is we've learned so far. So if you're watching this back on YouTube, then one of the things I'm going to ask you to do is just pause the video and then answer this question. So what I'd like to do is write down the success criteria to summarize how it is that you might increase or decrease an amount by a given percentage, using either a non-calculator or a calculator technique. So to summarize, if you're using the non-calculator technique, you're going to be working out what the percentage of the amount is first of all. If it was an increasing question, then what you'd want to do is add that amount to the original number. If it was a decreasing question, you would then take it away. However, if it was a calculator question, using the non-calculator technique is time consuming, so we're going to employ the concept of using a decimal multiplier in order to be able to work this out. So if it was an increasing question, add that percentage onto 100%, convert this into a decimal, and then multiply the amount by that decimal. If it was a decreasing question, take the percentage away from 100%, convert it into a decimal, and then multiply it by that amount. So let's have a look at a few examples here. I'll try and use both the calculator and the non-calculator technique for the first one, but I might use just the calculator technique to answer the remaining two. So to answer the first one then, increase 15 by 10%. So increase 15 by 10%. So if I know that 100% is 15, 10% is 1.5. Now because I know what 10% is, I can just add 15 and 1.5 together and give me 16.5. If I was using the calculator technique then, in this case I would start off with 100%, it's an increased question, so I'm going to add 10% on. And therefore, what I want to work out is 110% of 15. Divide 110% by 100 would give me 1.1. Of means multiply, and 1.1 times 15. This again gives me 16.5 as my answer. Moving on to question 2 then. This time it was decrease 30 by 40%. Now I could work out what 40% of 30 is and then take that amount away from 30. I'm going to use the calculator technique, so I'm going to start off with 100%. Because it is a decreasing question, I'm going to take away 40%, and that means that I'm going to be left with 60%. So I want to work out what 60% of 30 is. So divide 60 by 100 would give me 0.6, and if I do 0.6 times by 30 on a calculator, I then get 18. Moving on to question 3. Increase 50 by 42%. Now, as the percentages get more and more increasingly difficult, or it becomes a more complex problem, we are likely to adopt just the calculator technique. So in this case, I want to increase, so I'll start with my 100%. I want to add on 42%, simply because it was an increasing question. And now I've got 142% of 50, which is what I want to work out. So divide 142 divided by 100 will give me 1.42, and if I then multiply that by 50, I then get 71. So we've gone through an increasing or decreasing a number by a given percentage using either one of the two techniques. So if you've got a calculator to hand, you may want to practice that. Or if you're thinking actually you want a little bit more practice with the non-calculator technique, what I'm going to ask you to do then is now flip onto your questions on the right hand side. You've again got 3 minutes to try and get through as many of these questions as you can. 3 minutes, off you go. Okay, last minute. Okay, so let's go through the answers then. So whilst you were working, I quickly went through and answered the questions myself. And here we've got a decrease 30 by 10%. I know what I start with is 100%, and we're decreasing, so I took away 10%. That left me 90%. So knowing that I'm going to be left with 90% of what 30 is, divide 90 by 100 gives me 0.9. 0.9 times by 30 is then 27. Final answer. So a couple of checks is that because I decreased 30 by 10%, I'm expecting my answer to be less than what I started with. And obviously 10% of 30 is 3, so take 3 away from 30 does give me 27. Moving on to the next one then, increase 20 by 60%. So I start with 100%, add on 60% gives me 160. So at the end of this, I'm expecting to find 160% of 20. Dividing 160 by 100 gives me 1.6, and 1.6 times by 20 is then 32. Increase 80 by 31%. So I start off with 100%, add on 31 because it's an increasing question, and that will give me 131%. 131% of 80, 1.31 times by 80 gives me 104.8. So we've now looked at a good number of concepts throughout today's lessons. How we convert a number into a percentage, how we find a percentage of a number, and how we increase or decrease a number by a given percentage. What I want to do is wrap up with one last question, which is the kind of what if. Now, you'll generally see these types of scenarios when it comes to banking. And here, I have a bank account that earns me 10% compound interest each year. Now, the word compound interest basically means that I'm going to get 10% added on to whatever I have at the end of each year. So what if I start my bank account with £100 and then I want to evaluate how much I will have after 1 year, 2 years, or 10 years? So for this type of question, what we're going to be looking at is a very similar technique to what we've just been using to find the increase or decrease of a particular amount. So I start off with £100, but after year 1, I want to be able to add on 10%. Now, another way of rewording this into the format that we've looked at so far, we want to increase the amount by 10%. So I want to do 1.1 times by 100, and then this would then give me 110. After the second year, because it's not going to stay the same amount of interest, because I want to now, after 2 years, add on another 10% onto this amount. Now, thinking it over in your head, would the amount of interest I earn in the second year be the same or more than what I earned in the first? Well, the correct answer would actually be more. So for this question, I now need to do 1.1 times by 110, because I want to work out what 110% of 110 is. So 1.1 times by 110 gives me £121. So after this first year, I earned only £10 interest. After my next year, I earn £11 interest. So I would expect the amount of interest that I earn after each year to increase. But notice a couple other things. After 1 year, I times by 1.1. After a second year, I times this again by 1.1 to give me £121. So what can I multiply 100 by in order to work out the answer of 121 after 2 years? Well, the correct answer is to think about the interest rate, which was 10%, so I'm adding it on. But because I'm timesing it by 1.1 and by 1.1, I'm multiplying it twice. So I'm squaring 1.1 and timesing it by 100, and if I did this on a calculator, it would then give me 121. Now, if we then think about an easy way of doing it for 3 years, I could start with what my original amount is, times it by 1.1, but this time cube it. So this number represents the number of years that we are investing our money. So 100 times by 1.1 cubed would then give me £133.10 after 3 years. So on your calculator, see if you can work out what the interest after 10 years might be if I was earning 10% interest on each go. So hopefully on the calculator you did 100 times by 1.1, but raising 1.1 to the power 10. After 10 years, if I didn't touch the money, didn't put any more in, didn't take any out, that £100 after 10 years would grow to £259.37. So this is how we've built up our lesson throughout today's discussions into a real life context. At this point, if you are looking to invest your money in a bank account, then this is some of the calculations that you could do in order to consider how much money you'd have after a particular time period. So what I want to do then is think about some practice questions. And for this, we're going to move over onto the MWB website that was in the description if you haven't clicked on it already. So we are going to be using this software, and if you've used the link, you've probably gone to somewhere like this. If not, you've actually launched straight into the software and you've got to this screen. In the search bar, I'd like you to type in percentage. And as soon as you do that, you can see that it's pulled out the three things that we've been looking at in today's lesson. I'm going to ask that you spend about 10 minutes on these activities, and like always, all you need to do is select the single star if you'd like to be able to have a go at the more basic concepts, and selecting the 1-star question will just keep bringing these up. Move on to the 2-star, makes the percentages slightly more difficult, 3-star and 4-star. At any point you can click the answer button and just double check how well you've done with each of these. Or if you wanted to be able to look at all questions all in one go, then you'd select the All-Star button. Now the All-Star will bring up all levels of a particular question, and in this case I'm actually going to leave these questions up on the screen because it does cover quite a number of concepts which are really good thinking questions. So if you are watching this back on YouTube, you may wish to pause the video now and skip out the 10-minute gap that I'm now going to allow everybody else to be able to have a go at these questions. Or if you are using the website, please independently choose the ones that are most appropriate for you. In particular, the ones that I quite enjoyed writing were the growth and decay questions, which were about the idea of interest, investing money, and in particular, we've got this really good problem-solving question here, and I'm interested to see how many people would actually be able to do that. But going back to the increasing or decreasing question, you've got 10 minutes to now have a go at these questions. If you've got any comments, by all means put them into the comment section of YouTube and I will reply as quickly as possible. But otherwise, 10 minutes, off you go. Okay, and let's finish there. Let's just quickly go through the answers that I left on the screen. However, if you have been doing the independent work using the website, you should have been able to answer and mark your questions as you went along. So let's just check the successfulness of these questions on screen. Decrease 70 by 80%, you should have been left with 14. Increase 60 by 35%, you would have got 81 to 2 decimal places, or just 81. Decrease 50 by 43%, you would have got 28.5. Decrease 50 by 13.5, you would have ended up with 43.25 to 2 decimal places. Describe what happens in this calculation. Now, as you can see, this number is greater than 1, so it must have been an increasing question. And because it's 1.23, I must have been increasing 40 by 23%. And finally, the last one, explain why 48% decrease followed by a 48% increase is not the original number that I started with. Now, if you do take away 48%, you'll have 52% of the number. And if I then increase that number by 48%, that would be 1.48. And if you notice, 0.52 times by 1.48 is not 1. So I'm actually working out what 76.96% of the original number is, but through a 48% decrease and a 48% increase. Now, I hope that today's lesson has been fairly useful. One of the things I wanted to ask you to do, and I'm quite interested for you to post this on social media or email me if you know my school email address, is to summarize your learning in one of two ways. Okay, so number one, it could be that I'd like to condense your learning and send it to me through images, and it could be that in this case I've got increased 20 by 50%. And I think this would be a great way of visualizing what it is that you've learned in today's lesson. If you want something that's a little bit more of a challenge and you've liked the banking aspect of today's lesson, then by all means, please do catch up in my next lesson, which is going to be on Thursday at 10 o'clock. Now for this, you will need to practice certainly our understanding of bank accounts. So here I've got a very similar problem to what we had before. I have a bank account that earns 10% compound interest each year. If I start my bank account with only £100 in it, how long will it take me to become a millionaire? So I'm interested again for you to post your calculations as to how you managed to arrive at your answer based on today's lesson. Please do comment in the comment section if you wanted to post on there anyway. So, thank you very much for watching. Please leave positive or constructive feedback on the video. Thumbs up if you liked it, subs if you loved it. Feel free to carry on using the website hbkportal.co.uk/mwb/home. And if you want to have a look at my schedule of what other videos are coming up in the line, then hbkportal.co.uk/mwb/live videos. Thank you very much. See you next time.